Hello and welcome everyone to this conversation with customer with Quintus Technologies. Today I'm happy to have a guest with us here, Paul Talon from Burloak Technology in Canada. So very welcome, Paul. And maybe you can start us off here and introduce yourself and tell us a little about what you do at Burloak and a little bit about Burloak Technology.
Sure thing. Hi there. So my name is Paul, and I'm a materials engineer here at Burloak Technologies. We have the ability to be a serial production, a part manufacturer, specifically with additive manufacturing. We produce parts for our customers ranging in industries from aerospace and space to automotive and energy.
Can you please describe the products and the services that you use for Quintus today in your operations?
Absolutely. We partnered with Quintus just over a year ago, and we purchased the QIH 60, the Hot Isostatic Press by Quintus. And since then, we've been working with Quintus to add it into our post-processing of our additive manufacturing parts.
Can you tell us a little bit what materials are you printing and what parts, what do they go into? What benefit do you see with the hipping additive manufactured parts?
So we primarily produce aluminum, titanium, high nickel, and steel alloys that are used in multiple industries, like I said. So these parts that go into specifically, let's say, space or aerospace, they need to have a certain amount of fatigue strength. And you can imagine a part on an airplane or a spacecraft is going to be shaken a lot. So it's very important that if we produce a part, let's say a titanium part, that there's no porosity within it. So this is the HIP method, the Hot Isostatic Press, is a way of removing these internal pores. Now, this is a technology that came out of casting. So traditionally, you could cast these alloys, titanium or aluminum, to go onto an airplane. But if we're going to 3D print it, it's kind of handled in the same manner.
Maybe you can tell us a little more how the Quintus press fits into your total production line.
Absolutely. So the press itself fits in downstream of the production method. For example, we'll print something in the printer, and after that, we'll put it through a heat treatment, and one would be a hot isostatic press. Bringing this technology in-house has, like I said, decreased the lead time, but also given us better control over the quality of these parts.
Are you using the high-pressure heat treatment capability of the system?
We use it on our most of our parts when it comes to aluminum and titanium and some high nickel alloys as well. The capability of the Quintus is such that we can really make it an efficient process with its fast cooling rates, as well as do a lot of internal research and development. Now that we have this new toy for me as a materials engineer to play with, I can really develop some high efficiency processes which can produce really interesting properties that we can definitely flow down into our customers.
Can you tell us a little bit about why you picked Quintus as a partner?
We went into quite a deep dive into this technology before purchasing. Obviously, it's a pretty big expense and a big commitment to bringing something in-house like this and producing a process in which we can control it. So we looked into Quintus and saw that they were very safe. The technology was to the point at which we needed it to be. It's been a very great partnership for us, and I really look forward to continuing it. And also, thank you so much for not only the machine, but then the collaboration and all the support. Thank you.
Yeah, thank you so much, Paul. We also appreciate the collaboration and partnership with Burloak, and looking forward to continue for many years to come. And thank you personally too for the time today and good conversation together. So thank you, Paul.
Oh, thank you too so much.